What happened then? I think I somehow went live when I wasn't expecting to. All right, all right. Loud noises. Yeah, laptop is doing silly things. Is this even working? Do I have audio? Do I have video? I am in my usual state of confusion. All right, so before my brain totally explodes, Crispian says yes. We hear whether you like it or not. Thanks, Gerald. It's working. Hey, Sion. Okay, before I get into saying hello to everybody, first, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, good
Are
morning.
we there yet? Ha ha.
Aha, we have TTS even. So this is a, hang on, I've got to get myself back into the list of people. Okay, so good morning to Andrew Gordon, Crispian, Stephen W. Amanda is here. Cool. Gerald42, DIY in the Ghetto, Jack's Tech, Henrik, Sion is here, Tabraze, Johnny Bergdahl, my hot friend from Sweden, Sharky. I hope you don't mind that I say that. David Howes, Annie Mills is here.
Big fan noises.
Big fan noises, yes. That is the laptop that is running, like it's a very old laptop that is running OBS and it is running the Stream Deck setup. I wonder if I close it. If I close it, it'll go to sleep and then I won't be able to use the Stream Deck. But that might be worth the sacrifice. Let's see. I'm gonna close it and we'll see what happens. Oh, this should send that laptop to sleep. Hopefully it won't end the stream. Oh no, it hasn't gone to sleep because it is plugged into the ATEM. Good morning to David Crisp, Curtis Brooks, Cassio, Keith H, Mr. Barbecue is here, James Derrick, Curtis Brooks, I just said. Why, Cassio, why is it repeating? Don S from NZ. Install amphetamine on it. Wait, what? No buffering? Okay, so I am running a very dodgy streaming setup right now. You know when systems are really, really complex and they become fragile because they're complex, and you get that network effect. Network effect is when the value of a system increases exponentially with the number of nodes. The opposite of network effect is the fragility of a system. There should be a term for this. Does anybody know? The fragility of a system increases exponentially with the number of nodes in the system. So when I've got an unstable streaming setup with too many things in it that keep breaking, the obvious solution is add more things.
Said, "Happy late Christmas to you, Mr. Squirrel Man."
Merry Christmas, Henrik. I hope you had a very nice Christmas there in Estonia. And what is it like over there at the moment? Is there plenty of snow? Is it just freezing cold? What's it like? I want to have a Christmas in Estonia. That would be really, really cool. Oh, Stephen W says depends if the nodes are redundant or not. James Derrick says n times n minus 1. Complexity penalty.
Henrik Ostrov said, "Zero snow."
Zero snow. Oh, okay, so it's just super, super cold. What is the name of the warm mulled wine that is traditionally drunk?
Henrik Ostrov said, "Only good food, dirt, AMD, rain."
Okay. Good food, dirt and rain. Well, that doesn't sound so good. Apart from the good food. Good food is good. Something that starts with G. What is... Oh, hang on. Why does my Stream Deck think that it's on air? I am going to try... Okay, I might be about to kill the stream. Glue, that's it. Glue-vine. Yeah, I'm going to hit off. My Stream Deck thinks that it is a... Okay. I'm going to try something. I may go off air. Let's see what happens. I've pressed the button. And now that says it's off. For some reason, my Stream Deck was trying to stream. And OBS was streaming. Okay, so back to my very, very dodgy setup, which is I've got OBS running on my old laptop, which is controlled by Companion. Companion is connected to my Stream Deck. So the Stream Deck connects to Companion. Companion controls OBS and also controls the ATEM. Now the output from the ATEM, so the ATEM is capturing OBS off my laptop while being controlled by it. The output from the ATEM...
What is the colourful thing on the back of the bench?
On the back of the bench? Where? What bench? You mean back behind me? Which thing? Do you mean that? That's a 3D printer. Do you mean those? Those are boxes of things, of different projects and parts and stuff. And then I have a second instance of OBS running on my main computer, and that is taking the output from the ATEM over USB as a webcam and ingesting it, and then that is doing the streaming up to YouTube. The only thing we're not doing is bouncing.
Said, the thing with green, yellow, blue on it.
Green, yellow, blue. The only thing we're not doing is bouncing off a satellite into the back of Mr. Big's limo. But we could do that. Black box, yellow stripe. Black box, yellow... I see what you're saying. My view of the stream, that part of the view is blocked because there's a VU meter that jumps up and down on the left side. And I can't even, like over in this area here, on my right, I actually can't even see that on my preview window because it's blocked by the VU meter. But that's not exciting at all. That's just a box of 3D printer filament. Okay, my lab is the biggest mess ever right now. So I'm going to show you something. This is going to be a test. Can I scene switch while I'm streaming through OBS without breaking it? So I'm going to send a command to OBS on my laptop. Anyway, let's see what happens. I'm going to press this button, see if any smoke comes out. It worked. It worked. Amazing. Oh, yeah. That photo again, that desktop is the view just outside, just near the back gate at my mum's place.
Henrik Ostrov says,
yes.
At least is your mind clean?
My mind is never clean. It's never clear and never clean. And yeah, check this out. I just took some photos right before the stream because I wanted to show you the chaos that I'm currently in. So the reason for the chaos is this. I gave a little bit of a preview of this last weekend. The pick and place machines are now rolled way back to the back of the cleanish room. And you can see, oh, and also on Discord, I've been posting a few progress photos of this. So some of you will have seen this, others won't. You can see there's new lighting in there now. What I did was rip out all of the old lighting in the cleanish room, and I've installed this hexagon grid light. I'll find some pictures of that somewhere as well. So I removed the compressed air.
A dirty mind is a terrible thing to waste.
I know, Scott. Yeah, my dirty mind is totally wasted. So it's not being put to any use at all. So yeah, I disconnected the compressed air, the fume extraction, all the electricals, the networking. You can see there's an Ethernet cable hanging from the ceiling there. That was the Ethernet socket that was screwed up on the ceiling, and there are cables hanging everywhere. So I moved the pick and place machines down to the back of the room, and then I spent nearly 2 days with a mini roller and a paintbrush painting the beams. Hang on, I've got to find some pictures for you. Let's see. I want, what directory do I want? Camera uploads. So I posted some stuff in Discord. I've just got to find those pictures. Oh yes. Okay. Progress shots.
So you did Scrooby ripping up.
This was the this is some segments of the hexagon lighting that I just plugged together on the floor to power it up and see what it looked like. And then this was early in the process when I was starting to take out all of the lighting. You can see, is that light running? I can't actually tell. I have a feeling that this, well, yeah, that light is turned on even though it's hanging down like that. So I started by taking out the old LED battens that were in there, moving stuff around, and then moving everything to the back corner, and it all got very dark. Once I started disconnecting those lights, I had to bring in work lights. And then I started putting in, here we go. You can see that at this point I'd started putting in the edges of the box for the hexagon lighting, and it's got the strip across the front and most of the strip down this side and part of the strip down that side. And I was...
Henrik Ostrov said, lights never run, they just emit light.
Yeah, they don't run. The photons run. They run very, very quickly. At approximately 299,792,456
Henrik Ostrov said, I have never seen lights to have legs.
meters per second. So the plus or minus 0.24, I think, is the margin for error on that, on the speed of light. So I was trying to get these lights straight. So what I did was hang them up, and I was using electrical tape to try to get them aligned before permanently fixing them in place. And I 3D printed some little clips that go over the top of the extrusion, and then I could screw that into the beam. So these are all attached now. That was early in the process. And then this one was just after I got the outline complete.
John, are you Psych's doctor?
I what? I couldn't understand what that was. Are you a psychics doctor? Oh, I don't know. Yeah, on right shoulder. Sorry, I'm missing. Hang on, did someone say? Oh yeah, that was about installing methamphetamines on the laptop. Coffee. Half Greek Geek. Hello, welcome. I should check the chat. Who else has arrived? So
Pete said coffee.
Scott is here. Matt Latimer is here. Mark Laguda. I'm not sure who this is. A Hare is here. And Half Greek Geek. And Pete. Pete, you lost squirrel. Merry Christmas, Pete. Austin is here too. Yes, you haven't popped up in the chat participant list yet. Okay. Oh, Jack's Tech said amphetamine is a Mac tool that stops it from sleeping. Oh, so not the fun type of amphetamines then. Yeah, what's actually stopping it from sleeping now is the fact that it is plugged into the ATEM to capture its screen, its output from OBS. So even though I have now closed the laptop, it is still awake. Yeah, because it's running as if it's got one external monitor. What am I saying? That's right. So this was when I'd put the border around it, and you can see little bits of tape and stuff that I was using for marking the center line. I put a string line down the length of the room, measured from the center to the center, which is actually turned out to be not that easy, because the question is, what is the center? Because the room is not a rectangle. It has, on the right hand side, it's got this alcove off to the right where the old Cray supercomputer rack is sitting, and then on the left it has an intrusion on the left, and then the bench is inset to the left. So it's like the front of it has a bigger gap on the right and an intrusion on the left, and then further down the room it's all offset to the left. So
Pete said, your face stops it from sleeping.
Thanks, Pete. Yeah, my face gives everything nightmares. So I picked the center of the room as if it was between the right wall just here.
Henrik Ostrov said, at least will your mind be clean at the start of the new year 2025. Let the dirty things be behind in year 2024.
Henrik, no, I think my mind will always be dirty. But that could just be a terminology issue. So, okay. As for some of you who were chatting to me on Discord during the week know, I was mentally not in a very good place for most of the week. And yeah, I'm kind of okay. But yeah, struggles. I am... Do I chase this squirrel or not? Do I? My strategy when... my strategy is to run faster and distract myself. The problem is when I get to think, when I allow myself to think and to feel. So to prevent myself from feeling, I throw myself into things. And that's what I'm doing now. Okay. So what I did was decide the center line of the room I consider to be based on the right wall on here, which is a nice clear, it's a good clear straight boundary. And on the left, I took the center as being above the bench. So you can see on the left hand side here, there is this workbench that's inset. And I took the front of the bench as being the edge of the room. So imagining that bench is kind of like inset into where the wall would be. So the front of the cupboards and everything like that. Midpoint of the room I took as from the front of the cupboards to this wall over here. And then I aligned the lighting based on that. And one of the tricks was to get it as straight as possible, because when you're standing in the room looking at this, hang on, I'm going to see if I can find another view. Well, here's a slightly different view. When you're standing in the room, pretty much where I'm sitting now, so where I'm sitting right at this moment, if I turn to my left, I am looking exactly down the line of this right-hand edge of lights. And if there is even a slight kink or waver or anything in it, it's really obvious. So I used the blue painter's tape and attached. So what I did was I put the little 3D printed clips on top of the extrusions and aligned it with the beams. Used the painter's tape to string it up at each of the intermediate points, and I adjusted it like millimeter by millimeter at each of the beams, and kept coming back and eyelining down that line here, and I used this as my reference line. So I made sure that was as straight as possible. And it's not absolutely perfect because the segments of the lights, it's made up of segments plugged together. Some of the segments are not perfectly straight. They've got like a very slight bend in them, but I tried to pull it all straight with the positions of the clips. And the result is actually kind of okay. It looks pretty good. And then when you add the intermediate stuff, so this and this, this was starting to set up the hexagon lights on the floor in the clean room. And here you can see the first few segments turned on. I assembled it face down because it needed to just be lifted straight up to attach to the beams to go up on the ceiling. So I assembled it sitting on all of these little pieces of foam. These are bits of foam that come, some people might recognize these. Yeah, we'll know where these come from. I have so many of these. I've got like vertical meters of stacks of these bits of foam because I get one of these in every solder stencil that I get. So every time I get stencils from JLC, I get another piece of foam in it. And I've got, yeah, the stack is like higher than me off the floor. So yeah, that was, and you can see the system here, it's kind of like Lego, big Lego. These segments of lights plug into these connectors, and there are different connectors for different parts of it. So this one's a 207, what was it? 130 degree connector, 130 degrees that way. I think, I can't remember. Yeah, and there are the three-way connectors there. Then there are straight connectors and there are right angle connectors. So you plug them together to make the pattern. Is anybody still here? Dodgy. Dodgy! Dodgy is here. 120 degrees. Yes, Stephen W., you are correct. It is 120 degrees. Why did I not? How did my brain not math that? So, who else is here? Andrew Ruthven has arrived. Andrew, are you
Pete
going?
said, nah, we all left.
Okay, thanks, Pete. That's good. I scared you away. Andrew, are you going to Adelaide for Everything Open? I just booked my accommodation and ticket and stuff a few days ago, so I am definitely going. Got to see, yeah, Keith H. 130 is John's version of a hexagon. Russell Rainey is here. Dodgy Brothers is here. Dodgy Brothers Engineering. Oh, Andrew, you won't be making it to Everything Open. That's a pity. Scott says in JavaScript, 100.
Austin's_creation said, are you presenting?
No, I'm not presenting. In fact, this is going to be the first time in, I gotta work it out, I think 21 years that I have not either presented at the conference or run a mini-conf, or both. So I am going to be totally 100% relaxed. I will be able to
Unexpected Maker
just
said,
hang around.
Are the LED strips from the Hex thing RGB or just white? Sorry if I missed you mentioning this.
Hey, no worries, Sion. Yeah, they're just white. They are 6500 Kelvin. So because I wanted it a kind of, I didn't want a warm or yellow look. I wanted a very stark white look because I'm going for that medical bay on a spaceship effect. So yeah, so I'm going to be able to just enjoy the conference for the first time, I think, ever, since the first one I went to. So the first LCA I ever went to, I didn't present, and I didn't run a mini conf because I was just turning up as a newbie, had no idea what was going on, didn't have a clue. So I didn't do anything on the first one. But then the second LCA I went to, I ran the Debian mini conf, which was a 2-day conference. And I've been doing, there was actually one year I ran 2 mini confs on the same conference on 2 consecutive days, and spoke at the conference as well, I think. So none of that. I'm too tired for that stuff now. You know what, as Murtaugh would say, I'm too old for this. Where? Sorry, I'm looking for photos. No. Do I have? I'm sure that I have photos of the complete thing.
Pete said, old man.
Yeah, I am. I am ancient, Pete. So old. Jeff is here as well. Jeff Lethbridge, thanks for coming. Now, Crispian says live stream from the event. Maybe. Yep. Find a local open mat in Adelaide, says Don S. Yeah, maybe I should take my gi. And yeah, it looks like I'm going to drive over for rather than fly. I could still book a plane ticket, but I haven't yet. So my general idea is Adelaide is close enough that I can just jump in the car and drive there. It's not a problem. I've driven there before. And then I'd have a car at the other end, which could be convenient and be able to get out and do some stuff. Maybe, yeah, this is a serious stretch, but I could even go diving or something while I'm there. I could chuck my gear. The big advantage of driving over is that I don't have to care about luggage limits. I can just like throw stuff in the boot of my car. It doesn't matter what I take.
Pete said, I went to a barbecue on Boxing Day and this young person said there's this really ancient TV show called Hitchhiker's Guide, and I started crying.
Hitchhiker's, yeah, there's a really ancient TV show called Hitchhiker's Guide. Yeah. Who remembers that show? That TV show. It's not a TV show. As in, yes, I know there is a TV show of it. Sorry, pausing because I thought there was a car pulling up outside. No, it'll only ever be. I was going to say.
Scott Miller said, with enough ambition, you can drive to the West Coast.
Yeah, you can. My dad has ridden his bike from, I think he rode it from Perth to Melbourne with a sidecar, like a motorbike with a sidecar, with camping gear in the sidecar. But that was a long time ago, back before the highway was all properly paved and everything the whole way across. Because for a while he had a job doing weighbridge inspection on the railway line that runs across Australia. So he would get out on the road with his motorbike and sidecar and ride along, following the railway line essentially, and going to the weighbridge. The weighbridge is along the way, and inspecting them to make sure they were all doing their job. So he ended up riding his motorbike across the Nullarbor.
Austin's _ creations said, have you ever watched the World Solar Race? Next one is 2025.
No, I don't think I have ever watched the World Solar Race. I actually don't. What has happened to my photos? I'm sure that I posted photos of the. Hang on, I got to check in my phone. Yeah, why are these photos not? This is very strange. So these photos are not in my camera folder, but they are on my phone. So I don't know where they've got to. Sorry, I'm looking up because I just saw that my nephew Matt arrived at the door and then saw I was streaming and walked away again. That's all right, he'll probably come through in a minute. So that probably means that Tom is out there as well, is my guess. Maybe, don't know. Wagon Loads. Wagon Loads is here too. As you can tell, I'm not doing anything very productive today. I'm just talking to all of you. I had this idea. I've got some ideas for things to do on the stream today, but it's already half an hour in and I'm just talking crap. So, yes, I've got some more photos to show you. More photos. Photos of welding. Some of the things that I've been doing during the week. Like this. And hang on, I'm going to go back. I've got to find what has happened. All right, what I'm going to do is open Photos on my Mac, as in Apple Photos.
Austin's_creations said, have you had the AQS running while doing work in the cleanish room?
Ah, I have not, sadly. Why? Not enough local storage. Oh, have I run out of space on my computer? Because that would be sad. I have. I've only got 8.5 gig left on the disk in my Mac Mini. That's why these photos and things aren't syncing. Yeah, okay. I'm going to have to do something about cleaning up some space on my computer. That's weird because I had about 200 gig available just like last time I checked, which is not that long ago. It was maybe a couple of weeks ago. I don't know where all the space has gone. But that means I can't show you photos. Although I wonder if... Ooh, okay, I'm going to risk opening Discord. No, I'm going to make you suffer by staring at my face while Discord is opening.
Unexpected Maker said, Newsbreak John starts 100 projects this week and finishes none.
Start 100? That's, I think I'll start a few more than that.
Pete said, sorry not sorry, off watching the new Bobby Fingers video.
Okay, go watch Bobby Fingers. Where is the channel? Because I know that I uploaded Superlab build. Here we go. All right, I'm going to... yes, here we go. I'm going to stick... Risk it all, stick Discord up.
Said, 100 is a slow week.
Here we go. So, Discord. This was photos that I stuck up on Discord showing the progress. I would have uploaded these directly from my phone. And this is the point that you've seen to. So you saw this and the hexagon starting to work. So this was once I had assembled more of the hexagons. And the way I did this was I bought 2 garages worth of lighting. And this is 1 garage worth. So this is enough space to cover a car space. And the idea was to assemble the hexagons on the floor and then raise them vertically to put them inside that rectangular outline that you saw a moment ago. And then I transferred them to these steel purlins. So Lachlan is doing some walls out in his part of the factory, and he bought these excuse me, these purlins for attaching plasterboard, and I borrowed them because they were absolutely perfect as supports to put this on, to lift it up, because they're folded metal and they're quite rigid. So over the space of 6 meters or so, they're very self-supporting. They don't fold down, but they're still light. So I ended up putting 3 underneath, and by sort of lifting the grid and sliding it under, and then I started raising the grid, and I discovered that I only needed 2. So I just had these 2, and you can see that it's supported on stacks of the white foam to get it up off the ground. So at this point, the hexagon grid was sitting on the beams. And then next step, yes, Anakin, it's working. So next step was to put straps around. And this is looking up. You can see at this point the hexagons. So I used these these ratchet straps, not with the ratchets. I just used the strap part and tied knots in it, and looped it around and hung the purlins from the beams. And you can just see here that the hexagon grid is sitting on top of those, on top of these silver purlins. So it's holding it up almost in the position that it finally needs to go. And what that meant was that I could, the grid was sitting just below the beams that it needed to be attached to, and I could slide it around a little and get the position just right, and then put the clips in. So it was being held up in the position I needed it. And you can see there the corner of one of the 3D printed clips screwed into the beam. And then I've got to paint these white. So I'm going to paint the screw heads white to make those disappear as well. And then this, which is with the grid turned on, obviously, because you can see that. Why am I stating the obvious? Same thing, just let's go open in browser. And
Ostrov said, did you run out of straps that you had to use a cable as well?
Kinda. If you're referring to, if you're referring to this, you can see the off-cut bits of mains cable here. So these are bits of cable that were previously joining the LED lighting battens that I took out. So I ended up with a few lengths of cable that were maybe 1.5 meters long. And what I did was just put that up over the beam and twist it to act as a support. And you can also see some oki straps here. So I used a combination of things, because what I had to do, I did all of this on my own. And this is 6 meters long and nearly 4 meters, like 3.8 meters or something wide. So what I had to do was go to one corner, raise it a bit, tie it off, go to another corner, raise it a bit, tie it off, and I just kept going around and around and around like that. And by moving it in like 25 centimeter increments at a time, I slowly moved the entire matrix up to the ceiling. And at different points I had oki straps around it, I had electrical cable tied around different things, I had these tie down straps, just using the tails of the straps. At one point the whole thing was just hanging on oki straps, and it was sort of like a trampoline until I I moved it up higher and got it tied up into place. So then it ended up like this, which is kind of cool. And you can just see a little 3D printed clip there. At a couple of places the factory clips happen to align with where the beams were, and so they are attached directly. But in other places I had to use these little clips that I designed. And that's the result. Oh, and the other thing is, you see, when you're looking at this, see these big rectangular black things? That's the end of one of the purlins, because we've got the beams that go across horizontally here.
Outside the box said, should have called Ghostbusters. I mean Crispian. I would have brought the Corolla, which has a tow bar.
Well, thanks, Crispian. That's very generous, but it's a long way to come from Ballarat just to help with a little job like this. So you can see the ends of the purlins, which look black, which is horrible. I wanted to make those vanish. So one of the other things that I did was,
Scott Miller said,
after that,
I have a big pile of the tail ends of CAT6 spools. Might have to get into light hanging.
Oh, yeah. So you got lots and lots of little bits of Cat 6. So what I ended up doing was laser cutting some pieces to make end caps. I cut this piece with little holes in it for a reason you'll see in a minute, and I cut rectangular pieces without holes that were slightly larger. So these pieces, the white part, is the same profile as the end of the purlins. It's 50 millimeters by 100 millimeters with rounded corners. And then the clear piece, which you can see sitting on top of it with the holes in it, is a little bit smaller so that it fits inside the end of the purlin. And the reason that I cut these holes was to be able to just put drips of super glue in there so that it would make it strong. So a lot of the strength of the bond between these two layers is because I dripped super glue into these holes, which then wicked into the joint between the two so that the two faces end up becoming quite strongly glued together. And then I put a couple of drops of super glue around the edge as well. But the result was plugs that could go into the ends of those purlins, and kind of like this. So this is without it being fully finished. You can see that there's still some painting to be done there. So what I did was plug the ends of the purlins, and there ended up being about 30 that I had to plug. When I first did this, I actually designed a 3D printed plug to go into this, and I printed one because I thought, oh yeah, I'll just 3D print plugs to go into the ends of these, and it took nearly an hour to print, and I needed 30 of them. Well, give or take 30, something like within a few of 30 plus or minus 3. Got to have an error bar on all of our stats. So so I thought, I can't do 30 plus hours of 3D printing. I don't have the patience for that. Laser cutter is much faster, which is why I designed these laser cut versions, and then painted over it. So yesterday I got up with a paintbrush, a little paintbrush, and I painted over all of these end plugs and touched up all of the bits of the purlins and beams that needed it. Like you can see here, this this part of the purlin wasn't painted properly because I used a mini roller on the other part of it and I didn't get to this part. So I spent ages yesterday with a little paintbrush going around painting all of the little patches that hadn't been painted and painting over the purlins. Oh, sorry, painting over the end plugs so that they would totally vanish. And now when you look in there, you don't have the effect of those little black rectangles. Everything just looks white above the lights, which is cool. And then got into this. Somewhere here I think I have photos. Yes, photos. So this was welding up the hang on, I'm going to open, what am I going to open? All of those. Yeah. So this was starting to weld up the stands for the pick and place machines. You get this blue bar across the top here is a clamp. So that clamps all the way, like the whole thing all the way across the thing, and this is one of the legs. And then you can see the bottom bar. We're looking at this upside down at the moment, and the things weren't properly in position. So the large bar goes on the bottom, little bar goes on the top, and the little bar actually ends up, yeah, as you can see there, it's skewed. This was before anything was properly in position. It was just getting things approximately in place to figure out how we were going to clamp everything and lay it all up for welding. And that was with one of the mounting plates just sitting in place. So as you can see, nothing welded yet. This is going to be one of the plates that the pick and place machine sits on. So there's one plate like this on each corner, and they go over the position where the feet currently are on the machine, and then with a hole through that so that the machine will be bolted down to the stand. And then let's see, Ooh, what happened then? Okay. Then we've got this, not a very interesting photo, and a weld that I'm not too ashamed of. So I'll show you this one because it doesn't look too bad. Then this was towards the end of assembling the main frame. So the two sides were done flat on the bench as separate pieces. You can see the bench under here, this steel plate. That's my friend Steve's welding bench, and it weighs about half a ton, I think. It's it's an enormous steel plate with holes in it. So these are threaded holes for like M16 or M12 bolts or something, so that he can put in tie downs. So you can see there's a bolt through there with a tie down, so it's clamping this part of the leg down to the bench. So what we did was make the two, what should we do? Front and back? Yeah, we did the front, and then we did the back, and then stood them on their edges and joined them into a box by putting, you can see here, this is another piece clamped in place. There's a top piece clamped in place, and then welded all of those and turned the whole thing into a big box. So it's now at the point where the first stand is essentially in this shape. It's a complete box, but it doesn't yet have the plates on the top for the machine to mount on, or the plates on the bottom for the adjustable feet. That's the next stage. What else? I thought there was another thing that opened. I don't know. Anyway, yeah. So that's just showing you laying up the job ready to weld the other pieces on. Nobody has said anything on TTS for a while, and chat has been out of my sight. So yeah. Still went for safety. Hang on, I've got to try to catch back up with chat a little bit. Safety flip-flops on then, says Don S. Yeah. No, Steve takes welding safety very seriously, very, very seriously. And I was wearing leather shoes, cotton trousers, and a welding jacket, like a leather welding jacket with protection on the arms, wearing big gloves.
Squirrel, 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 squirrel.
Yeah, you're failing to distract me. So I was wearing big gloves with silicone across the back of them, which if you get sparks and stuff on it, it means that it doesn't burn you. And welding helmet, of course, and a hat to protect my head. We're here. Thanks, Don. Yeah. Oh, and the other thing that Steve is really cautious about is you never weld to the end of the day, because what can happen is when you're doing MIG welding in particular, more than with TIG welding.
Outside the box said, haven't you had sunburn from welding before?
I have, and I don't want to have it again. I do not want welding sunburn. So when you're MIG welding, sparks can fly many, many meters. You get bits of molten metal sprayed across the place. And if something molten ends up running in like under a bench, against a bit of cloth or whatever, you can have something catch fire an hour after you've finished welding. Particularly if there is material lying around in a typical sort of factory situation where there might be oil on things, or the sort of situation. So one of the things that one of Steve's rules is, when you finish welding, do not leave the building for 2 hours. So if anything does happen to catch on fire in the aftermath of welding, then you are there to do something about it. But yeah, what a lot of people do, particularly in like work situations, working in a factory, is they will be welding all day, get to the end of the day, tools down, and walk out the door. And that is how you get factory fires. So we're not going to do that. Donna says fire watch. Yep. Yes. Very good. So don't finish welding, put your tools down and walk away. Hang around, pay attention. Anyway, so you can see here the frame coming together. And so the frame is, I'm trying to remember the dimensions. It is something like 1150 millimeters in one dimension and 1080 in the other dimension. So it's fairly big. It's a pretty big box, as you could see from some of those other photos. And once we'd finished, we were dimensionally accurate across the entire thing to less than 1 millimeter, which I was pretty chuffed about. I thought that was very impressive. Steve was like, oh yeah, it's okay. Yeah, his standards of precision are very, very high. So yeah, it was sub 1 millimeter difference diagonally across the entire frame. Low enough voltage. Okay, what have I missed in the chat? Yeah, low volts, high amps. It can be in the welder I was using is a 200 amp welder, but we didn't have it turned up that high. It was probably running, I don't know, 120, 130 amps, give or take, something like that. So yes, yeah, Steve's got a I think a 500 amp welder as well, which is used for welding things like 1 inch thick plate. So yes. What am I doing? What am I doing? Okay, I'm just talking about random crap, aren't I? It's like an end of year picture show and tell. So yeah, it's a mess. Yeah, you can see here these feet that the pick and place machines are on are coming off, and these feet have M20 threads on them. It's a big M20 bolt that goes up through the bottom of the machine, and the foot is coming off, and then the machine is going to sit directly on the stand that has been welded up with an M20 bolt going through the stand up into the machine. So the machines will be hard coupled directly onto the steel stands, which are heavy. So I don't actually know how much. So far they don't have that. They're probably going to be in the region of 60 kilos is my guess. So each stand, yeah. I should actually weigh one to see what it is, but my guess is somewhere in the order of 60 kilos per stand. So yeah. So at the moment I can pick them up. I could pick up one of the stands myself without any trouble. But they are heavy, and they're going to get heavier. We were actually thinking about maybe putting ballast in them as well. There are a couple of ways that could be done.
Austin's_creation said, does this mean you have some conveyors ready?
Ah, Austin, good question. I will get to that in just a moment. So yeah, we were thinking of a couple of things. One is filling the legs of the stands. They are 100 millimeter square section. I think it's 100 millimeters square, and I think it's 3 millimeter wall. So each of those legs is quite heavy. But what we can do is we could actually fill the legs to add weight, or we can add a tray down in like the middle area. We could make a tray that fits into it and then put stone or pieces of granite or something in it to add more mass. Jacksek said lead shot or sand. Yeah, Stephen says fill the tubes with sand or cement. That's right. Or just gravel or something. Let it settle. Yeah, things like you can get pieces of granite. It's actually not that hard to get offcuts of kitchen benches. If you go to a place that does custom kitchens, what they do is they have sheets of granite or, the different materials, marble, whatever, all the different things that are used for doing kitchen benches. But then inevitably they cut out holes for sinks and cut little like discs out for plumbing, for taps. They cut corners off to, cut a corner off to make an angle into a corner. They'll trim them and end up with little offcuts. So anywhere that does custom kitchens will have a big dump bin full of pieces of, random pieces of granite and marble and whatever other benchtop material. So yeah, getting decent sized chunks of granite is not that hard.
My machine weighs 65-ish kilograms. It has a
Yep.
direct drive electric motor on it. The old one, however, has a full motor with a clutch on the bottom, and it is way heavier.
Aha, nice. Yep, that sounds good, Amy. You got a new machine. That's cool. Yeah, so Scott says, imagine the stands made as a solid casting. Yeah, okay, so there is a complication here, which is mass matters, but resonance matters more. Is that a real saying? I don't know. I just came up with something. James says, custom kitchen deliveries, money for nothing and your chooks for free. So the the whole thing here is to stop vibration, and typically vibration will happen at certain frequencies. There will be harmonics. Any object will have a native resonant frequency at which standing waves will form within the material, and the vibration will continue for a while. Like it takes a while to damp down. So the trick is removing the harmonics that matter, and often that means just making things heavier, and that then pushes the frequency up. So you get, you move the harmonics way up into a region where it doesn't matter. But it's not as simple as just make things heavier. So yeah, heavier is good generally as a rule of thumb, but it is not the only thing. And one way to do it is to use fine material like, looking at this photo, imagine that the trolley that the machine is sitting on was the top of the stand that it's bolted to. So and then this could be a tray that you could fill with, say, gravel and sand, or it could be lead shot or something like that. And because there is something that goes on, because there is a difference between filling that cavity with something solid like concrete versus filling it with gravel. And the way energy transfers through the material, if it is separate particles, is different. Now, in this situation where I want everything clean, I wouldn't use something fine like sand. but something like gravel would be a possibility, like crushed rock. And particularly if it's enclosed, like you have a tray in the stand and you fill it with crushed rock, and then you have a cover that goes over it so that you don't get rock dust and stuff coming out, but you get the effect of the material that settles and it kind of interlocks with itself, and it absorbs a lot of energy. Oh, Wagon Load says fish tank gravel. Yeah. Jackstack says water sloshes and will form resonances in its container unless it's completely full. Yeah. Or you add mass at the antinode, says Jackstack. Yeah. I mean, all of this is interesting to theorize about, but you can go overboard with theorizing. I tend to, in this sort of situation where there is the opportunity to adjust things, well, firstly, it's not that critical. Secondly, there is the opportunity to adjust things. I take the eclectic empiricist approach rather than the theoretical approach. So I'm not going to sit there for hours with doing like an analysis of the materials, doing a finite element analysis and figuring out resonant frequencies, doing a model of the thing with the material characteristics, etc. No. I'll just build it and see what happens. And if it turns out to be a screw up, well, it's a screw up, but at least it's my screw up. So I'm going to, yeah, I got to install it. Donna says the DIY CNC boys use granite and resin. Yeah. Okay, so does Bunnings sell 0.5? Yeah, okay, so James, David said crushed rock still has lots of dust in it, almost worse than sand. Yeah, you're right. So that's why it would need to be enclosed. James said, does Bunnings sell 0.5 metre slabs for paving? Paving slabs or cinder blocks work well for 3D printer stand inertia damping. Yeah, absolutely. That's right, paving blocks. There are so many heavy things that could be chucked into it if it turns out to be necessary. I have a feeling that it's not going to be necessary. Now so Don S pointed out the DIY CNC boys use granite and resin. Now the frequencies that you're dealing with in CNC are different to pick and place. So what we have with CNC is a cutting tool which is spinning at a fairly high speed. It might, it can be potentially in the tens of thousands of RPM sort of range. So we've got a high speed, we've got a high frequency resonance coming from the cutting tool. And then the machine itself is typically moving quite slowly. As it's moving, like cutting through the material, it's moving at a few millimeters a second, but it's not zipping around really quickly. And the head is usually quite heavy. So you have high frequency plus large mass, which is engaged, putting a lot of force as it's moving laterally. Pick and place is kind of the opposite. We don't have the super high frequency from the cutting tool because we just have the vacuum pickup nozzles. The head itself is very light. It's designed to be as light as possible because it needs to be thrown around. You need lots of acceleration and the highest speed possible as you're moving the head. So the head on pick and place machines moves way faster than the head on a CNC machine. It's like, it's really quick, but its mass is much less and it doesn't have the high frequency of the rotating tool to deal with. So yeah, similar problem, but it's just different parts of the spectrum. James says, dumb engineer wants heavy things on stand. Yep. Scott says, the human body is good at absorbing vibrations. Got any enemies? Okay. Yeah, you won't end up at the bottom of the harbour wearing a pair of lead boots. You will end up inside a pick and place machine. that moves the most. How to lift KO up onto stands? Asked Crispian. Okay, the current plan is I have two plans, and I'm not sure which. Simon says CNC can move fast depending on the job at hand. Doing an engraving in timber, the spindle gets moved around very fast. Yeah, that's true. So if you're cutting into a light material like timber or plastic, and you're using like a shallow pass with a small bit, then yes, it can move pretty quickly. But still, even a quick CNC machine we're talking about like an order of magnitude slower than a pick and place machine. It may look, yeah, fast for CNC is slow for pick and place, like glacially slow. Scott says, next barbecue will start with lifting practice. Barbecue day, lots of volunteers for lifting. Actually, that's not such a silly idea. What is it now? Okay, so we are now 2 weeks away from the next barbecue. Yeah, so yes, but typically no more than a couple of meters per minute. I wonder how fast I could time it, but like just as a, it can move, like this is real hand wavy time, but it's moving. I have a feeling that the KO head moves at about 4 meters a second, somewhere in that region. Yeah, I'm running them at half speed at the moment. So running at yeah, anyway, it's pretty quick. Donna said, will you set the base on the original feet attached to the base? The casters will have a lot of slop. Exactly, yes. So a large part of the reason for doing this is to get rid of this. Now, these stands were made by Cable Tie and myself when I was first setting up in this room. In fact, it was before the clean room existed.
Scott Miller said, calculations are a moot point. Directions are pretty random.
Yeah, that's right. The directions are all over the place. So yeah, when I was setting up, so before this room even existed, when this was just open factory space and I had a tent in here, or was it even before the tent? I can't remember. I can't remember the sequence. Cable Tie came over one afternoon and the two of us got out the circular saw and we made these 3 trolleys that the 3 pick and place machines are sitting on and used Lachlan's forklift to pick up the machines. So we just put the forklift straight under the machine, ran it under here. These things are really strong. The pick and place box, the cube of it is very rigid. It's got bracing running across in all the appropriate directions to prevent it from twisting and that sort of thing. So you can pick one of these machines up by one corner and the whole thing just stays like true. It doesn't twist or anything. They're very rigid. So anyway, we picked up each of the machines with Lachlan's forklift and put them on these trolleys. And the whole idea with that was just so that I could move them around, because when these machines are loaded up, they're a few hundred kilos. So yeah, somewhere in the order of 300 kilos. So I needed to be able to just shift them around and rearrange them. We put them on the trolleys and they haven't come off the trolleys since. And that's been, how long? A year and a half, maybe? They're still sitting on the trolleys. That is not where they are intended to run. And that's actually one of the reasons I could just put them down on the floor and then I could crank the speed up. So I'm running at 50% speed at the moment, because more than that and the trolleys just start throwing themselves around. Even when you put the locks on the wheels, just the slop, like the play in the wheels and everything, it's not good. The machines need to be much more physically anchored to be able to run at full speed. So my goal is to get them onto the stands, and there'll be adjustable feet on the bottom of the stands with like shock absorbing feet and adjustable for leveling to get them all perfectly level and aligned so that all the conveyor belts line up. Austin, yes, conveyor belts. That is about to be. In fact, I've got it back out. The conveyor belt is about to become a very, very important project. And also strategies. Sorry, my brain is firing all of these things that I want to talk about, and I've been largely ignoring them, hoping that it would come back to mind at the appropriate time. But something I want to talk about in a minute is strategies.
Outside the box said, could the KOs be trussed to the ceiling?
Could they be trussed to the ceiling? I don't think that would help. Potentially, but I don't think so. Strategies for loading and using the machines and job processing. I'm going to get back to that. Please, someone remind me of that topic if I don't get to it. What was I talking about? I don't know. Okay, so yeah, adjustable feet. That's right. So what I have considered is bolting the stands, like dyno bolting the stands to the concrete, and that would make them absolutely rock solid. But I think I need leveling feet. So my current plan is to transfer these leveling feet from the bottoms of the machines to the bottoms of the stands, with the stands hard coupled to them. And I think by having the increased mass of the stand and that it is hard coupled to the machine, it should make them much more stable, and then I'll be able to turn the speed up, get them running more quickly. Paul just said, reminder, strategies for loading and job scheduling. Yes, thank you very much, Paul. How much diagonal... Dodgy asked, how much diagonal bracing are you going to put into the stands? That is a very good question. Short answer is currently none. And why is that? No. I'm slightly lying. There will be some diagonal, but it is not going to be in the form of specific braces. It's going to be in the form of panels, because the bottom of the stand is going to have a flat panel in it. So we're talking about multiple axes here. If we're talking about the horizontal axis, I want to be able to put rubbish bins under the machines to catch all the tape output. Like you can see on this machine back here, see all of these loose ends of tape that come out. This is the excess from the pick and place tape. This one has had a haircut, so I've gone along with a pair of scissors and trimmed it. And I did that before I was doing the work on the room because I wanted to roll the machines around. But normally this tape just ends up coming out, and you end up with meters of tape just dumped out on the floor, which is annoying and messy and a safety hazard. So once these machines are on stands, I'm going to have like a bin under here that the tape goes into so that it's all contained. And James says there are locking casters with jacking levers. Yes, I know, that would be nice. So so what I'm going to do is put a platform in the bottom of the stand for things like the bins to sit on, and that will give it a huge amount of rigidity in the horizontal plane. Then there are diagonals in the vertical plane, well, multiple vertical planes, and I'm probably not going to have anything there.
Said, Squirrel Project, automatic tape trimmer.
Oh yeah, Scott, I have thought about that a lot. Horizontal mounted guillotine that cuts the tape off periodically, which I think Sion's machine has. I don't know how it actually works, like whether it's a guillotine, but I'm pretty sure the high-end machines have automated tape trimmers. So as the as it's basically like a shredder, I suppose, like a cross-cut shredder. So the tape comes down out of the machine into a receptacle, and then periodically it's chopped off, so that you end up with a bin full of short pieces of tape, which is much easier to deal with. Wagon Load says, can you put a paper shredder under the ends of the tapes? Yeah, it would need to be like a cross-cut shredder, because the problem is that normal shredders have two interlocking rods with discs, and the discs go between each other.
Tiny robot arm with scissors.
Yes, snip, snip, snip. Yeah, with like nail scissors. Yeah, they've got a normal paper shredder works by having a series of two discs that are interlocking, and they rotate, and the edges between the discs are the cutting edge, which is why you get vertical strips of paper coming out of a normal shredder. What this needs is, instead of doing vertical cuts like that, it needs to be horizontal cuts. So it would need to be something like a guillotine that comes
Henry
across horizontally.
Said, I just thought the same thing can you. Make a hot wire to cut it, and it moves right to left and back.
A hot wire? No, but the problem is that most of the paper is, most of the tape is paper for the 0603 parts. There is the plastic cover over the tape, but then the tape itself is cardboard, essentially, or paper. So a hot wire might just cause a little fire. That wouldn't be so good. Jackstack says, vertical shredders are not secure anymore. Yeah, because all you need to do is lay all of the pieces of shredded paper out, take a photo, feed it into a computer, and the computer reassembles it all. So yeah, you really have to go to a lot more trouble these days to make paper records irretrievable. You can even, depending on how it's been, oh, Jackstack says have done it. Nice. Depending on how it's done, you can even sometimes retrieve records that have been burned. Yeah, if it hasn't been broken up afterwards. Wagon loads, can it be cut by laser? Put a burner under it, asks Henrik. Oh, I'm not going to set the clean room on fire. Scott pointed out, typical shredder pulls the paper in two, would be problematic. Yeah, so just a normal off-the-shelf shredder would not be suitable for this application. I would need to build something. And Tabraze just asked an interesting question, which will come through the text-to-speech in just a moment.
Tabraze Malik said, can you have an empty reel to rewind the tape and seal film? The two rails would be linked to main reel, not sure on what reel holder you have.
Yeah, so that question is related to re-reeling the tape. So instead of just dumping it out in like a big pile of spaghetti, have the tape come down onto another reel so that as it's fed through, it's being rolled up again. I think that would be more trouble than it's worth. It's an interesting idea to braze, but it would end up being another mechanism that could fail and tangle and cause problems. So the simplest solution is just to have this go down into a bin, and it's going to sort of jam up in the bin, and I'll still periodically have to go across with scissors and cut it off, but at least it'll be contained and won't dump on the floor. Jackstack said, thermal printer dumping straight into a shredder. Tiny robot with scissors. Yes. Oh, Pete. Completely off-stream topic. Well, hey. But on topic for John.
Definitely leaning towards the tiny robot with scissors.
Yes. Tiny robot with scissors. That would be classic. And it could be a machine learning, machine vision sort of problem as well. So we've got to train a robot. In fact, we could use the universal robot. We've got Lachlan's UR10 or whatever it is, UR15, I can't remember. Universal robot down the back, which for welding and chainsawing and stuff. We could attach some little scissors to that and teach the UR10 how to find the tape and cut it off. That would be funny. Pete said, completely off-stream topic, but on topic for John, because everything is on topic for me. Bobby Fingers has created an eye prosthetic for a mate, and has put an NFC inside it so payment can be made by waving the terminal over his eye. Oh, that's funny. Or, the way I visualize that is not so much wave the terminal over his eye, but put his face against the terminal. So you go up to the checkout in a shop and they want you to tap it and you just stick your face down on it.
Amanda Thompson said,
And it
train
takes-
squirrel to cut the paper tape and get nuts for rewards.
And it takes payment. Yes, Amanda, train squirrel to cut the paper tape and get nuts for rewards. So I've got to keep a supply of nuts and squirrels and scissors in the clean room and hope nothing goes wrong. I can think of everything going wrong. Bucket vacuum. Don S said 20-litre bucket vacuum on timer.
Henrik Ostrov said, make it a game like the one where you have to cut the rope to get the plushie, here you have to cut the real leftovers.
Cut to get the plushie. Yeah, and that seems to tie into Stephen W. says, seems much simpler and cheaper to just use child labour and a pair of scissors. Child labour, right. Everyone is someone's child. Oh, Jack Tech said, there's a great Tom Scott video about shredding your comments. It was a great demo. What's shredding your comments? I want to find that. Tom Scott. I was just watching a Tom Scott video a day or two ago. He just did a video a couple of days ago.
Scott Miller said, squirrel poop everywhere.
Yeah, squirrel poop everywhere. About microdosing. Tom Scott and shred comments. We shred your comments live. 7 years ago. No? Was that him? Yeah, Tom Scott and Matt Gray are shredding YouTube comments. Okay, so it prints and destroys the comments. Yeah. We shred your comments live. Right. Okay. Now, what else? What else? Oh, okay. Okay, so Paul asked, I might have missed it, but why not put machines directly on the floor? Well, Paul, I am very glad you asked, because that leads into bringing back one of the topics that was kind of just skipped over earlier, which is the conveyors between them. The reason I can't just put them on the floor is I need the conveyor belts on the machines to be all at the exact same height, and that height has to be at the same height as the reflow oven. And the reflow oven is significantly higher. I could lower the oven. I could make like a, like those fake villages that you see. I don't know why, but I just imagine them being in Germany, like a miniature village where you can walk around and you can see all the little houses and things. I could make it like that, where everything is down on the floor. But it wouldn't be very convenient to walk on, to work on. Everything would be novelty low. No, there is a standard for the height of conveyors on electronics production lines, and it is the SMEMA stand. Like SMEMA is what does SMEMA stand for? It's something like Society of Mechanical and Electrical Manufacturing or something like that. Where is it? Oh no, Surface Mount Equipment Manufacturers Association. Okay, so these people. Close. Get rid of that. These people. They merged with the IPC to form the IPC SMEMA Council. So, Surface Mount Equipment Manufacturers Association. Because you can just imagine that if you have... Oh, here we go. It even says it here. Look at this. Conveyor height. Each machine shall have the transport conveyor height adjustable from 940 to 965 millimeters, 37 to 38 inches, from the floor to the bottom of the PC board. Fixed rail, for the purposes of the standard, the front rail is defined as the fixed rail. Yep, tooling pins, etc. And the whole idea here is, oh, and it's got the ready in, ready out. Yeah, board available and machine ready. So board available is ready out, and machine ready is ready in. If you're thinking in more general factory production line sort of terminology. And the whole point of this is that if you buy a board destacker and a solder stencil printer and an inspection conveyor and a solder like optical inspection machine and a pick and place machine and then another manual inspection conveyor and a reflow oven and then a board stacker from different manufacturers, you need to be able to make them work together. And if you just plonk them down on your factory floor and the conveyors are all at dramatically different heights, then you can't get them. Or one of them has the front rail fixed, and when it adjusts the width of its conveyor belt, the back rail moves, and another machine does the opposite, you can't get any interoperability between the machines. So these SMEMA standards are just some basic specifications that explain how machines should be set up so that you can use them all together. And yeah, so yeah, that was a very good question, Paul. But the reason is this. This is the critical thing. I need to make sure that the conveyor height on these machines is within this range so that I can then get the output from the machines going onto an inspection conveyor and then from that into the reflow oven. So my target is, well, my original target was going to be 950 millimeters. That's what my goal was for these, to get it within that margin of the standard. But there was a screw up. When I ordered the parts for welding up, I'm going to see if I can find the photo. Somewhere back here I had a photo. I might have already closed it. Yeah, I think I've already closed it. But I can reopen it. Okay. This photo here shows, yeah. So this is looking up. So this plate here is the plate that the pick and place machine will be sitting on. So this is looking sort of from inside imagine you're inside the middle of the stand looking diagonally up towards one corner. And this is what it would look like from if you were sitting on the ground looking up underneath the machine. There's going to be a hole right about here and then an M20 bolt going through that into the bottom of the pick and place machine. And you see this plate right here. When I was placing the order for the steel, I told them that I wanted 16 pieces because I'm making two machines and I want top and bottom plates. So a total of 16 pieces of steel plate, 150 by 150 by 10 millimeters. So that was what this plate was meant to be. And when I got it back, it was not 10 millimeters. This is actually 16 millimeter thick plate, and they screwed up and misread my cut list. So what they gave, whoever it was, so my specifications very clearly said quantity 16, 150 by 150 by 10. And whoever was looking at it just went, in their head, they went, 16. It's 16 millimeter. So they ended up cutting it out of 16 millimeter plate. What that means is that my stands are now 12 millimeters higher than they should be, because there was going to be 10 millimeter plate on the top, 10 millimeter plate on the bottom. Now there are two 16 millimeter plates, which means I have gained 6 millimeters each top and bottom, which means 12 millimeters. So my stands are now 12 millimeters higher than I wanted them to be. And yeah, the result is, yes, gaze upon that chaos. Yeah. is such a mess. It breaks my mind when it's like this, but it's inevitable. It gets to a certain point where, in order to make progress, to rearrange the room, I had to commit to, I am just going to rip everything apart. Everything is going to end up in piles on the floor. Nothing is where it's meant to be, but this is a transition period that I've got to get through to get to the other side. And that is to allow this, with everything moved out of the way, so that I can then work on the ceiling and put in the stands and that sort of thing. And in the meantime, I have to live with the chaos. There's just stuff everywhere. Right. Yeah, my phone is on silent mode and it's still dinging because the mute switch is broken on my phone now after its trip to the bottom of the ocean. What am I doing?
Scott Miller said, "There, just hack 12 millimeters out of the middle, weld them back together, or grind the floor down 12 millimeters."
Yeah, grind the floor down 12 millimeters. So the James says dig a hole in the floor for the reflow oven. Yeah. The to couple machines to the floor. Yep. Paul said the feet are engineered there to couple machines to the floor. Yes. Can't the conveyor be at an angle between the reflow and the pick and place? Oh, it probably could. It probably could. Then, what was I talking about? Yeah, so the result of all of this is, if we look at, hang on, the S-MEMA standard, my target of 950 millimeters. I had designed the stands so that the machines would end up at exactly 950 millimeters above the floor. But now they are going to end up at 962 millimeters above the floor because of the extra 12 millimeters. And it puts it only just inside the upper limit of the margin for the position, and that kind of makes me uncomfortable. I want to bring it down a little bit more. So what I'm probably going to do is, this is allowing for a couple of things. It's allowing for feet under the machine, and it is allowing, the feet that it's allowing for are the feet that are already on the machine. So there are a couple of things I can do. One is I can get different feet. So I could get lower profile feet that then gives me the margin that I need to be able to adjust it. The second thing I can do, this is Steve's suggestion, is at the moment they have very big lock nuts under them. In fact, I wonder if I've got a photo. One of the photos I had open a moment ago actually showed it. So if not very well, but probably well enough for our purposes. I could just go and take a photo and show it to you, but no, then it wouldn't sync. All right, this photo, I think on this photo, I can probably get in close enough to show you what I mean. Now, if we zoom in, where's the focus bit? Yeah, okay. Look at this. This is one of the feet. And these are specifically designed for this purpose. They've got the shock absorption properties, and they've got bolt down, like tie down. You can see there are 2 holes through it. So you can actually bolt these feet to the floor and stop them moving around, but then the shock absorption properties in them will still be in effect. So what you can see here, you see the 2 nuts. It looks like 2 nuts. This bottom one is part of the shaft that goes all the way through. So there is a vertical M20 threaded rod that goes all the way through here, up through the machine. It's and this bottom one here, that is the one that you put a spanner onto to turn to raise and lower the legs. And there is like a little ball socket inside here. So the bottom of that rod, just in this area here, goes into a ball socket so that it can turn without the foot rotating. So the foot doesn't turn, you turn the rod that goes up through the machine, and it raises or lowers it. So that one is actually machined as part of the rod. I think it's all one piece. I think it was machined that way. It's not it looks like a nut that is sitting on it, but it's not. It's actually part of the shaft. Now the one above it, you see this one here, that's partly obscured by the base of the machine, that is a lock nut. So the idea is that you have it released, you adjust the height of the foot, you get everything perfectly level, and then you do up the lock nut, you raise it up so that it engages with the bottom of the body, and it stops this from being able to turn. Now the thing is, this lock nut is huge. It's like, I think it's 20 millimeters vertically. Like the actual length of the nut is 20 millimeters. It's enormous. So what that means is, well, Steve suggested that I chuck these in a lathe and turn them down. Basically take half the length off that, because it's not a structural nut really, it's just a lock nut. It's not taking the weight of the machine, it's just jamming up against the body of it to stop the thread from rotating and therefore the height of the machine from changing. So we could easily take that from a 20 millimeter nut down to a 10 millimeter nut. So I could do that. Yeah. I could turn it down to make it a 10 millimeter nut, and that would gain me back the 10 millimeters that I need based on, yeah, it'll gain me back almost the 12 millimeters and put me right back in the sweet spot.
That's a valid solution.
Yeah. And the other thing I could do is just buy new nuts. I could buy half thickness nuts and not have to bother with turning it down in the lathe. And in fact, this is probably the best solution, because one of the things that I still need to do is buy the nut to weld onto the bottom of the stand for this to go into. So what I could do is use these nuts. I could take these nuts off, weld them onto the stands, and then buy M20 half thickness nuts, like short nuts, and use those as the lock nuts in here. So I think that's probably going to be the neatest solution to all of this. So it's annoying that those plates ended up being 16 millimeters instead of 10 millimeters thick, but we can compensate. We can change things. Swivel foot, yes, half nuts, says Don S. Yeah, so David asked, can't you just get them to supply 10 millimeter as requested? And yeah, I could, but it's actually not bad having those really heavy plates. It's a bit of extra mass. It's going to be super rigid. The only downside to it is the fact that the material costs a little bit more than 10 millimeter, and and I've got this height issue that I now need to compensate for. But yeah, and Crispian said countersink into the plates. Henrik asked, can you 3D print the nuts? Not out of anything that would be strong enough. They need to have very strong threads, because you've got to tighten them up hard against the base of the machine to really tension them and stop anything from moving. Maybe? I wonder if, yeah, I don't know. No, I wouldn't. For this application, this is many hundreds of kilos of machinery with everything bolted down tight and hard to prevent any movement. I wouldn't use plastic or 3D printed parts for this. So yeah, I'm going to go for proper stainless steel parts. Oh, Graham Brown. Did I miss why you're only making 2 stands and not 3? No, you didn't miss it. I've kind of touched on it in previous live streams, but not today. That comes down to how much time have I got left? Not all that long. There are so many things I could talk about in relation to this. Okay, I might come back to that in a moment. The short version is I can't fit 3 machines in the line. By the time I add the reflow oven, the inspection conveyors, room for a stencil printer at the front end, board stacker, all of that sort of thing, I just do not physically have space for the 3 machines. And realistically, I am not going to use all 3. So my strategy is I'm going to have 2 machines on the line, hot, running, and then I'm going to have the 3rd machine as a spare. So it can be sitting ready to go, and if I end up having a machine totally die or some serious problem with one of the 2 live machines, the 3rd one can be commissioned, can be brought in on the line. Yeah, as Scott said, machine number 3 is the spare. Henrik asked, can I look up, do I have the half nuts? No, I don't have M20 half nuts. I'll need to buy some. Don said, with 16mm plate, I would suggest you tap the plate, as tacking those nuts will shrink them and cause binding. Yes. So I could do that for the feet under there. Yeah, 16mm plate is thick enough that I could legitimately just tap the plate and the thread would be good and strong. Like an M20 bolt through 10mm plate, you could tap it and it would be okay, but all of the stress is through those threads. But with 16mm, you're right, I could legitimately just tap those holes. Crispian says, push further into Lachlan's factory. Yeah, I've been talking to him about that. It is very real possibility that I may be able to gain another 4.5 meters by going in under his mezzanine. So that could be a potential, particularly when I replace the reflow oven. And I do need to replace Bernie Boy. So the reflow oven that I currently have is physically very small as reflow ovens go. It's only, I think, about 1.8 meters long, maybe just over that. It's really small. Whereas a proper reflow, when I say proper, I mean like a decent reflow oven, they're typically 3.5 meters long. So and I do need a better reflow oven. Bernie Boy has been a really good solution for a $200 Facebook Marketplace purchase with rewiring and setting up the controller. It has been fantastic, and I've done thousands of boards through it, but it doesn't have, it's more radiant than convection. I need a proper convection oven with better temperature control, better temperature profiling. It's yeah, it's crude. You can tell that it's a 33-year-old reflow oven. It is not modern technology at all. So it's just 7.5 kilowatts of grunt and not a whole lot of
Imogen Ann said, when Bernie Boy is replaced, we can convert him into that forbidden pizza oven we have all been asking for lol.
The forbidden pizza oven. No, I would probably keep it as a spare so that I could commission it on the line. This is the thing, is that once I really need to have contingency plans for business continuity. When I am totally dependent on these machines, if a machine fails, I need to be able to get back and functioning quickly. If a pick and place machine fails, I need to be back online within a day or two. If my air compressor fails, I need the spare air compressor. So I have a couple of air compressors, and then beyond that I have backup options. Like I could run an air hose all the way through to Lachlan's big air compressor if I needed to. So if my primary air compressor fails, I could be back up and running within half an hour or so. But if the reflow oven fails, I am really seriously in trouble. I've got the old drawer style oven, which does still work. I could use that, but in terms of throughput, it is super limited compared to the conveyor oven, where you just keep feeding boards in the start and they just come out the end, and it never stops. Doing boards in the drawer style oven is much slower. It's a lot more overhead because you have to put the boards in, it runs through the whole thermal cycle, cools back down again, then you unload it and put the next lot in. So the number of boards per hour that you can run through is dramatically less than with the conveyor oven. So what I will probably do is, if I get a big reflow oven, I will take Bernie Boy and use the hoist and stick it up on the mezzanine, wrap it in plastic and put it in storage. So because the thing is that if a reflow oven fails, getting a replacement is not something that you can't go to your local Bunnings and buy a new one. It doesn't matter how much money you have, you cannot get a replacement quickly. It's going to be quite some time to get an enormous thing ordered and shipped and bring it in and set it all up. Don S said, ask Xeon for manufacturing time. Yeah, Xeon has his own things to do with his pick and place line. Wagon Loads asks, why can't you make the legs like a floor joist jack but much shorter? I'm not quite sure how that would work. Maybe I'm just failing to visualize it properly. Oh, Scott says, Diesel Creek posted a video starting the recommissioning of a nice 750 CFM compressor today. Yeah. Stephen W says, for enough money you could get Xeons. Yeah. $1 million. David said, now to find a 20mm tap. Yeah. So, a 20mm tap, yes. Oh, I'm sure I could find a 20mm tap. You can also tap on a CNC machine with the correct cutting tool. So that's what Steve does on on one of his CNC machines. He has a tool. I'm going to be all hand wavy about it because I don't really properly understand it. But basically what you do is you have a cutting tool which I think has like a triangular edge on it. It's like a disc. And then the CNC machine, because it's got so many axes, it can move the tool at different angles and the base and all of that sort of thing. What you do is, in the design software, you model the shape of the thread, and then the CNC machine actually cuts the thread inside the hole. And it means you can do arbitrary threads. Like you can do threads of different, whatever diameter you like, and different pitches, so the space between each of the loops of the thread, and different face angles on it, and all that sort of thing. So you can just arbitrarily make any thread you like by fully modeling it, and then by cutting it on the CNC machine. So yeah, that's what he's done. So he can do things like make threads that are impossible with a regular tap. So he was just telling me recently that you can do things like, imagine you need to make a thread that is on a 200mm hole, so a really big hole, but the hole is only 10mm deep. So you've only got like 2 or 3 turns of the thread for the entire hole. He can do that on the CNC machine. So if you had a situation where you needed a large hole with a thread for like a cap that screws into it or something like that. So yeah, 3D lathe. Yeah, he he's got CNC lathes and CNC mills, and the plasma cutter and lots of stuff. So yeah. Yeah, Dodgy says, that's the guts of how it works, but typically need a high-end CNC to get that complex. Yeah, you need lots of axes and things, which he has. So, yes. Jack's Tech said, tapping the plate is the correct way to do it. Yeah. Where are we now? Where are we now? I am just... Oh, Pancake Legend. Oh, Pancake Legend is here. Good to see you in the chat. I haven't looked in the chat list for a little while. So, Paul Schulz, I've already said hello to Paul. Pancake Legend, thanks for coming. Simon is here. Rob V. Bernie Johnson is here. Graham Brown is here. Yeah, so, okay. Strategies. I don't have much time left. I actually have a client coming over this afternoon, sadly. Why do I have a client coming on a Sunday afternoon in a holiday between Christmas and New Year? And the answer may shock you. The answer is, I have no boundaries and I let people take advantage. So, yes, okay. So what was I saying? That's right. So sequencing. Ooh. Don S just said, hang on, I'm going to read this. I haven't actually parsed this in my head yet. I'll see if it makes sense when I read it. A large angle iron welded vertically in place of the base corner bevel. A pocket to fit the 10mm, now 16mm, to sit inside the overall outline to lower the swivel foot close to flush with the bottom. Okay. And, I think it's kind of too late for that, because I've already got the frame welded up. The other thing is that so a couple of people have suggested just cut a bit off the length of the leg. Yeah, that's, on the face of it, that is the obvious thing to do. The trick is getting that cut perfectly perpendicular. The cuts that were done on all of those pieces were done at the steel supplier. They have all the facilities for cutting metal, all the different, they've got all the big tools necessary for doing that and doing it extremely accurately. So with those legs, for example, the cuts on those legs are exactly perpendicular. I can just, put it down on the ground and it just stands up and it's perfectly vertical. So the top and bottom faces of the leg that have been cut off are quite precisely parallel to each other. And if I tried to trim 16mm off by whatever technique, there is no way that I would get it as accurate as their cut. So I am using their cuts as the starting point for laying up the material and clamping it all in position and then welding. So, so Scott asked, were you originally planning to weld the nut on the bottom or top of the plate? I was planning to weld it on the top of the plate. And yes, I know that that means the welds will be under tension instead of compression, and it's not ideal. So the ideal thing would be to weld the nut on the bottom of the plate so that the force is going through the plate, through the interface between the nut and the plate. I'm not even sure why, actually. I do not remember why the plan was to weld it on the top, on the inside. Don't know. I don't know. Yeah, guess that eliminates the quick solution. Yeah, and also the height of the cross pieces on the bottom is set so that we can put a pallet jack underneath it to lift the whole thing, because I want to be able to move them around once they're on the stands. So the crossbar at the top is right at the top. The crossbar at the bottom is specifically at a position that gives enough clearance off the floor to be able to run a pallet jack under it, like an extended pallet jack that does the whole size of the machine, or forklift tines or whatever. But they're deliberately high enough to fit a pallet jack plus packing material. Now, what was I doing? That's right. Now, there was a video a little while ago, which was a tour of, hang on, I'm going to find this. I'm just going to hit mute on here. It was Strange Parts Tour of Prusa Factory. I'm going to find it and bring up just some stills to show you the, where is the pick and place part of the line? Oh, here we go. Pause. And what am I going to do? I'm going to, once again, make you stare at my face because you've been very naughty and I want to make you suffer. So, okay. Back to here. Yes, okay, so this is Scotty from Strange Parts on the left doing a tour of the Prusa factory, and this is their pick and place production line. Now, seeing this has totally changed my opinion on how to run my machines. Well, seeing this and having a conversation with Tom, we've been talking through the workflow of how to increase our throughput and take advantage of having multiple machines. And Wagon Loads said use a screw jack. That's Crispian says, why? What did Jack do? Well, Jack got lucky, didn't he? Jealous of Jack. So Scotty here is standing in front of the Prusa production line, and they have, I think it's 4 or 5 machines. You can see the reflow oven there. Like, that reflow oven is huge. That's like 4 meters long or something, 5 meters long. Somewhere, oh no, this is onto the, oh yeah, look at that. You can see there, that's their reflow oven. Makes Bernie Boy look like a novelty toy. Oh, here they have storage for reels. So this storage system goes up and down, like, I think he said 5 meters or 7 meters vertically. You can see all of these trays, and then each one of these trays is filled with reels. And what they do is on the touchscreen, they dial up the parts they want, and it's like a big vertical carousel. It rotates around to bring the trays with the parts you want to the front and then brings them out to you. So it's yeah, it's a way of bulk storing lots and lots of parts in a climate controlled way. But where are we? Back to the back to the pick and place machines. I'm just going to play this for a second to get to the spot I want and hopefully not get any copyright strikes. Yeah, I'm trying to get to this sort of area. So these are some of the feeders. This is on one of the not the first machine. It's a roller wall carousel, says Jack's Tech. Yep. Okay, split board loading so that each machine is spending the same time to load its board parts. Yes, okay, now here we go. I'm going to, how am I going to do this? I want to draw a diagram, but I'm instead just going to do lots of hand waves. Okay, now, my original idea was to have 2 machines commissioned and have one of the machines commissioned with all of the parts required for one particular client's boards, which is the water cannon client, T-Rex. So you already know about them. I can talk about them publicly. That's fine. And it would have all of the parts required for the bill of materials for T-Rex's boards, which has parts that aren't used on other boards. Then the other machine, I would make my general purpose machine. So it would have all generic parts loaded, you know, the 10K, 1K resistors, 100 nanofarad caps, all of the common things. So what I would do is use the second machine only for T-Rex boards and the first machine for everything else. And that way I could be running T-Rex boards on one machine and running other boards on the first machine, like for a different client. The problem is how to physically arrange that in the production line, because the conveyors would need to be at different widths. Really the only way to solve that is to not have a continuous conveyor all the way through, and to hand load boards. So carry boards to the input side of each of the two machines, and when they come out you pick them up and then you take them to the reflow oven. I can't really see a way around that, apart from crazy ideas like having double-decker conveyors, where the boards come out of the first machine, drop down, go under the second machine, and then come back up and go onto the reflow oven. Something like that, like crazy stuff. So the other solution is building two production lines. What I could do is the mechanical area that is out behind the loading dock, I could turn that into a second clean room and set up another production line. Then I could run two things in parallel. But that is a lot of extra stuff, and it's just not a great solution. So if only had a whiteboard to draw a whiteboard. Dodgy remembers that. Yes, Dodgy remembers the video where I was on a whiteboard and I drew a whiteboard on the whiteboard. That was a long time ago. So, okay, re-strategizing. Now, there are some factors here. One of the factors is the KOs do not have tool changes. You have to manually take the nozzle tips out and put different nozzle tips in if you want to change tools, which means that I currently, on the machine that I'm using, it's got 4 tips or 4 nozzles, and I've got 4 tips loaded, and they are different. They are all different sizes to cater for everything from like small parts, you know, 0603 type stuff, up to large parts like ICs, microcontrollers and things. So I have 4 different nozzles. What that means is the majority of the time that machine is running as if it's a single nozzle machine, because once it's put down the larger capacitors and those sorts of things, typically there will be a lot of jelly bean parts compared to the rest of the parts, just statistically. So once it's put the other parts down, it's only putting down one part at a time because it's only ever using the first nozzle. So this is my strategy, my rethought strategy. What I want to do is put the two machines together with a linking conveyor and treat them as one mega machine with 2 moving heads and 8 nozzles. So what I would do is have and then in the first machine, I can have 4 nozzles loaded that are all the same. So I'll have 4 nozzles specifically for 0603 parts, which means it'll always be running as 4 heads. Not 4 heads, 4 nozzles, which will minimize transit times. So it'll make it run faster. And then what I do is the first machine, I'm going to load with all feeders with nothing but 0603 parts. All resistors, all capacitors, LEDs, etc. in 0603. Nothing but 0603. And then the second machine won't have any nozzles in it that are for 0603 size. It'll only have large nozzles, and then in that it can have things like the bigger capacitors, microcontrollers, ICs, different switches, all of the things that need to be put down that have a larger footprint and need a larger nozzle. So what this means is the first machine should be very, very quick on putting down all of the 0603 parts because it'll have 4 nozzles working all the time. It'll always be in 4 nozzle mode. The second machine won't have to put as many parts down, but they'll be larger parts that are more varied. and so it'll have probably 4 nozzles on it, but there'll be a couple of different sizes. And I think that will give a balance where once the process has started, the first board has gone through the first machine and has gone to the second machine, and then the first machine is beginning on the second board, there will, most of the time there will be 2 boards being placed simultaneously. And I should get a fairly high efficiency because I'll have 2 heads moving simultaneously, up to 8 nozzles being used simultaneously, and then it'll give me the number of feeder slots that I need to be able to load every single part for every job that I do and have them loaded on the machines at all times. So I think that is the most efficient way to do it. But there is a complication, which is how do you do the software setup? And I think I can solve this. What I can do is, normally what you do is you set up OpenPNP so it knows what feeders it's got loaded. It's got a job defined where it knows what parts need to go on the job. And it's got the cross-reference, so we can look up, I need a 10K resistor that is in feeder 7. So it then pulls the part out of feeder 7. If you have a part that does not have a matching feeder, then it can't place it and it's got to be marked as disabled. So here's my plan. I am going to do a bit of a quick little Python program which will take an OpenPNP job. So what I can do is create a job that has all of the parts defined in it. I will then run it through a little parser because the OpenPNP uses XML. It's that easy to work with. So what I can do is just open the XML file, which is the OpenPNP job, make 2 copies of it. On one of the copies, I will enable all of the parts that are loaded in the first machine. Second copy, you enable the parts that are in the second machine, and then push those 2 configs to the 2 machines. So essentially you've got one job that has been split into 2 halves. One half on one machine, one half on the other. But I don't want to have to go through the process of doing that manually every time. I want to be able to just generate the pick and place job out of out of whatever, like KiCad or Fusion or whatever. And then, so we get the placement file out of Fusion or KiCad, run this parser that will then generate the 2 OpenPNP jobs, and then they run independently. So the machines don't know about each other, and they don't need to know about each other. They only need to know about the parts that they are putting on, and then the board moves on to the next machine. That is going to be so conceptually that sounds simple. There are some complications in it in relation to the way I want it to work with the machine configs and OpenPNP, but that's just Python. So yeah, it's a software problem. It's easy. It's not hard like hardware. So yeah, that's my plan. So new plan, ladies and gentlemen, boys and girls, everyone who has come here today, squirrels and magpies, 2 machines, daisy chained and in lockstep, so their conveyors always adjust to the same width, running the boards through both machines. Some parts placed on one machine, some parts placed on the other. That is the strategy. I'm going to give that a shot and see how far we go. Jacksec asked, does OpenPNP support multi-machines in one job? No, it doesn't. So that's where my little preprocessor script is going to come in. It's going to do that division between the 2 things. So one thing that my son Tom suggested, which is a really clever idea, and my first reaction was, no, that's ridiculous. And then I started thinking, that's actually really cool. I don't think it's possible, but he suggested trying to configure OpenPNP to control both machines simultaneously out of one copy of OpenPNP. So you have one job loaded. So essentially what we would do is define a custom machine with 2 moving heads. So you would have 2 x-axes, 2 y-axes, 2 well, actually you'd have 8 Z axes because you've got to have one Z axis for each nozzle. You'd have 8 rotational axes, and then you would tie them together with vertical axes. Oh, sorry, with virtual axes. And you would have to understand that it's talking to 2 motion controllers. So a motion controller for machine 1, a motion controller for machine 2. And I think you could probably do it. OpenPNP is flexible enough that you can define arbitrary axes. You can have 2 x-axes if you like. You can have 2 y-axes if you like. So, and it doesn't need to worry about the heads colliding because they are physically inside separate boxes. So I could treat it like one machine with 8 nozzles on 2 heads. It is theoretically possible, and it is so crazy that it just might work. But I think it might be a bit too ambitious for me to try to pull that off. So that was a very clever idea that he had. But I think what I'm going to do is set them up so that each of the machines can run in isolation off their own dedicated copy of OpenPNP running on a dedicated controller. Because of course you've got to consider that you also have to capture vision from all of this. We're doing real-time vision processing off the cameras in the machines. And we'd have to have multiple vision pipelines running in parallel. Yeah, I could probably do it, but it would be a stretch. So I'm going to make each machine run independently, and then I'm going to feed them with pre-processed jobs that only cover the things that those machines need to do. So, Scott Miller says, next trick, OpenPNP running 256 machines. Yeah, it goes back to the classic joke. Imagine a Beowulf cluster of pick and place machines. Massive parallelization. Yes, we'll start having to apply GPUs to do all of the job processing for them. Stephen says, do the simple thing first. You can always upgrade to the complex solution later. Yes, that's right. So this is following the principle that I have talked about a number of times before, which is progressive integration. That's my work mantra when I'm working on projects. Progressive integration. Don't try to do the perfect solution first up because you'll screw it up. Start with the big picture, the major building blocks, make the building blocks work together, progressively integrate them until you have a nice, neat, tightly integrated, tightly coupled system. But don't start tightly coupled until you have proven the overall system architecture works with loosely coupled blocks. So, progressive integration. That is my work strategy. So, yes, I'm going to have to go. I am going to have to go because my client is going to be here probably any minute now. And you probably have better things to do than stare at my ugly face all day. So, thank you very much for coming along. Oh, I've got to figure out how to end this stream because I've got this Frankenstein's monster of a streaming setup. Okay, I think I have found where to do it. I can do that and that. Yeah, okay. I've got a plan. So I'm not going to see you until next year. I hope you all have a fantastic New Year's Eve. I don't know what I'm going to be doing. Probably nothing. I'll probably be asleep. That's how boring I am. And as Crispian says, Uru, thank you everybody for coming along. Thank you for hanging out with me in 2024. I'm going to see you in 2025. The next week I'm going to be working like crazy during this downtime when my clients are gone so that I can get the clean room finished and back up and running, pick and place machines ready before my clients come back. That's the big challenge. That's the problem that I've got. I'm on a clock. I've got a deadline. So I can't screw around. I've just got to get it done. Thank you very much. And I will talk to you all again really soon. Come and see me in Discord. Thanks. Go and build something awesome. Yeah, that is screwed up. What am I exposing there? Okay, I'm exposing the desktop off the companion setup. Am I showing anything that I shouldn't be? No, I don't think so. Okay, anyway, I am going to go by, yeah, that's the laptop setup for controlling the streaming. So,